somewhere beneath the East China Sea, in total darkness, at a depth where the human body would be crushed in under a second. Engineers are building something that should not exist, a 500-kilometer tunnel connecting two of the most powerful nations on Earth. And the pressure trying to destroy it right now as you watch this is 40 times what you feel standing on solid ground. 40 atmospheres. That number alone has ended lesser projects before the first machine ever touched the seabed, but this is not a lesser project. This is the most expensive hole ever drilled into this planet, a $200 billion bet that two rival economies can build something together that neither could survive building alone. And by the time this video ends, you're going to understand exactly why the world's top engineers call this the last great impossible thing left to build on this planet. Picture the ocean floor between Japan and China, a stretch of seabed that looks calm on every map you've ever seen and completely hides the truth underneath it. An active fault line running directly through the planned route, a seam in the Earth's crust that shifts without warning, the kind of geological trap that has swallowed entire tunnel projects, and the reputations of the men who designed them long before the first meter of rock was ever cleared. Every engineer who signed onto this project knew that one miscalculation here doesn't mean a delay, it means a catastrophe measured in human lives, and international headlines that would echo for decades. And yet they came anyway, thousands of them, drawn from opposite sides of a border that has separated these two nations for centuries, brought together underground, where nationality means less than the steel in your hands and the seal on your suit, and the number blinking on the pressure gauge above your head. The boring machines used here are not machines in any ordinary sense. They are 12-story mechanical organisms with a cutter head, strong enough to chew through solid rock at 40,000 tons of raw thrust, grinding forward at a pace that sounds almost laughably slow, 20 meters a day, until you remember that every single one of those meters is being carved a mile beneath a merciless ocean, through rock that has never once felt sunlight, at a rate where a single second of downtime bleeds $1 million from the budget before anyone even has time to react. There is no pause button down here. There is no calling it a day. The machine runs, the pressure holds, or people die, and that tension sits behind every decision made on this project, from the first excavation to the final ribbon cutting, threading through every meeting, every blueprint, every sleepless night spent staring at seismic readouts. Now, here's the part almost nobody outside the project understood until the blueprints leaked. This isn't just a transportation tunnel. Buried inside the plan, hidden behind the engineering jargon about a central artery, is something no nation has ever attempted before. The largest observation structure ever built beneath the sea, a glass gallery running the entire length of the crossing, designed to let ordinary travelers stare directly into the abyss while trains scream past them at speeds that would tear an ordinary car apart on the surface. 2 tubes for high-speed rail, flanking a third tube built purely for wonder. And the moment you understand that a government spent $200 billion not just to move people, but to let them fall in love with the ocean floor, the entire project stops looking like infrastructure and starts looking like obsession. And obsession is exactly what it took to survive what came next. 3 years into construction, the survey teams monitoring the fault line detected a shift nobody had modeled, a tremor traveling through bedrock exactly where the eastern tube was scheduled to pass within the month, a discovery that arrived on a random Tuesday and changed the trajectory of the entire project overnight. For 6 days, the entire project stopped. 6 days of silence in a facility that had never gone silent, while geologists from both nations argued over data, recalculated stress points, and quietly wondered whether the whole crossing would need to be rerouted, an adjustment that could have added another 5 years and another $40 billion to a budget already stretched to its limit and a timeline already promised to 2 impatient governments. What they decided instead was almost reckless in its ambition. Instead of avoiding the fault, they would build straight through it, engineering flexible seismic joints capable of absorbing movement without cracking the shell, essentially teaching a rigid steel and concrete structure how to bend without breaking. The same principle that lets skyscrapers sway in an earthquake instead of shattering into rubble. It had never been attempted at this depth, under this pressure, across this distance, and every senior engineer on the project understood exactly what was at stake in that decision. If it failed, it would fail catastrophically, and everyone on the project knew it. If it worked, it would rewrite what deep sea engineering was capable of for the next century. They chose to bet on it working, and they signed their names to that bet, knowing full well what failure would cost. Down at the working face, the saturation divers were doing something that sounds almost mythological in a world of remote robotics, living for weeks at a time in pressurized chambers no larger than a shipping container, breathing an engineered gas mixture that lets the human body survive at depths where an ordinary diver's blood would boil with nitrogen the second they surfaced too fast, a condition so violent it can kill in minutes. These are considered the most dangerous jobs on the entire site. Men and Women who cannot simply go home at the end of a shift, who exist in a pressurized bubble for the length of an entire rotation, decompressing so slowly that the process itself can take longer than the work they were sent down to do in the first place. They handled the final seals, the connections no robot could be trusted to finish, tightening bolts that stood between a 500-kilometer tunnel and the full, crushing weight of the Pacific and East China Seas combined. Bolts that, if even one failed at depth, could trigger a chain reaction no rescue team could reach in time. Every bolt checked once, checked again, and checked a third time, because down here there is no such thing as good enough, only sealed and unsealed, alive and not, and the men doing that work knew the difference better than anyone standing on dry land ever could. Meanwhile, 6,000 tons of steel reinforcement were being sunk into every single kilometer of tunnel, an amount of raw material that would be enough to rebuild entire bridges on the surface several times over, poured as self-compacting concrete engineered so precisely that a single trapped air bubble was treated as a structural failure requiring immediate review, because at 40 atmospheres, weakness doesn't announce itself slowly. It waits, silent and patient, hidden behind a wall that looks perfect to the naked eye, and then it gives all at once, without warning, without mercy, and without a second chance to fix it. The breakthrough moment, when the two boring crews, one launched from the Japanese coast and one from the Chinese coast, finally met somewhere in the crushing dark beneath the sea, has entered engineering folklore already, and for good reason. Years of separate calculations, separate machines, separate national engineering teams working toward a single point they could never actually see, converged within 5 millimeters of the target, a number so small it barely registers as real when you first hear it. 5 millimeters, after 500 kilometers of independent boring through solid rock beneath an ocean that never once stopped trying to crush the structure being built inside it. To put that into perspective, that's a margin of error smaller than the width of a pencil, achieved across a distance you could fly over in less time than it takes to watch this video twice, a feat of coordinated precision that engineering professors will be teaching for generations. When the final wall came down and engineers from both nations stood face to face in a chamber that had never known daylight, there wasn't a translator needed for what that moment actually meant to everyone standing in that room. But breaking through was only the halfway point, because now came the part that separates a tunnel from a monument. The transformation of raw structural shell into the deep sea aquarium gallery that had been the project's secret ambition from day one, hidden in plain sight behind blueprints nobody outside the engineering team ever fully understood. 80-ton acrylic panels, clearer and stronger than anything used in ordinary construction, were lowered through specialized transport systems so delicate that a single visible scratch turned an 80-ton piece of engineering into a multi-million-dollar loss, discarded on the spot. Because at these depths, imperfection isn't cosmetic, it's a liability that could cost lives decades down the road. Molecular bonding agents fused each panel to the surrounding structure with a seal that engineers describe. Without. Exaggeration as stronger than the steel around it, because the ocean above never stops trying to reclaim what humans build beneath it. And the only answer to that relentless, patient pressure is chemistry precise enough to make failure statistically impossible over 100 years of continuous operation. Then came water treatment systems, capable of achieving 99.9% transparency. A standard so extreme that even the faintest haze in the water was treated as a design failure requiring a full systems review from top to bottom. Because the entire emotional promise of this project, the reason two governments justified $200 billion to their taxpayers, was a single unbroken view into the deep. Not a hazy window, but something closer to a portal into another world entirely. Marine biologists worked alongside structural engineers to recreate conditions mimicking the natural reefs of the Pacific, managing circadian lighting cycles for the creatures who would call this artificial reef home long after the construction crews had packed up and gone, filtering waste through massive natural biological systems instead of harsh chemical treatment. Because the vision was never a fish tank bolted onto a train tunnel, it was a living, breathing ecosystem stitched into the bones of a transportation network, something that had simply never existed anywhere on the planet at this scale or with this level of ambition. And then, quietly, almost as an afterthought, buried deep inside a systems report nobody outside the project ever expected to read closely, came one of the most human details of the entire build. Engineers installed underwater acoustic. Sensors capable of capturing whale song as it passed near the structure, not for scientific data alone, but because someone on the design team insisted that the people traveling through this tunnel deserved to hear the ocean they were crossing beneath, not just see it through glass from a moving train. That single decision, more than any of the 40,000-ton machines, or the 5mm breakthrough, or the $200 billion budget, tells you what kind of project this really became. An engineering marvel that somewhere along the way quietly turned into an act of reverence for the very thing it was built to conquer and contain. Before opening day, the entire structure faced its ultimate trial, full load testing at 50% above rated capacity, pushing every rib, every seam, every bolted connection to a stress level the tunnel would never actually experience in daily operation. Because the only way to trust something with human lives is to break it in. Theory before you ever let it carry a single passenger in reality, no matter how confident the calculations looked on paper. Engineers watched seismic sensors for even the faintest sign of structural echo, the telltale signature of a shell beginning to fail somewhere deep inside its own bones, and for hours that stretched the nerves of everyone on site to their absolute limit, they watched, and they waited, and nothing gave. The structure held. Every rib absorbed the punishing weight without a single visible flaw appearing anywhere along 500 kilometers of shell. And in that silence, in that moment when the readouts confirmed structural integrity at 100%, decades of combined careers, thousands of workers' sacrifices, and 2 governments' worth of political capital were finally validated in a single number glowing on a screen in an underground control room. When the tunnel officially opened, the first trains crossed at speeds exceeding 500 kilometers per hour, meaning a journey that once required a ferry crossing measured in hours or a flight. Burdened by airport delays and security lines, now takes roughly 40 minutes from coast to coast, an entire ocean compressed into less time than most people spend commuting to work every single morning of their lives. Passengers in the central gallery report an experience that engineers spent years trying to perfect and still describe as impossible to fully capture in words. Floating past the structure in near silence while a magnetic levitation system eliminates nearly all vibration, watching bioluminescent life drift past reinforced glass in the crushing dark of the midnight zone, feeling simultaneously like they are moving faster than anything on Earth and completely, perfectly still, suspended between 2 nations and 2 seas at the same time. The tunnel is powered largely through renewable and geothermal systems, drawing on the natural heat of the Earth's crust it was carved through, engineered to be self-sustaining for 48 hours in the event of any crisis, meaning the very ground that made this project so dangerous to build has become, in the end, part of what keeps it alive and breathing every single day. What started as a fault line that nearly canceled the entire crossing became, through 5 relentless years of engineering, testing, failure, and redesign, the foundation of a structure now expected to outlast the century, a maintenance-minimized design using oxygen-reduced environments to essentially stop the clock on corrosion, built not for a single generation, but for however many generations choose to keep crossing beneath these 2 seas long after everyone who built it is gone and forgotten. And maybe that's the real story hidden underneath every statistic in this video. Not the 40 atmospheres of pressure, not the 5mm margin of error, not even the $200 billion price tag that dominated every headline before construction even began, but the simple, stubborn decision made by 2 nations with a long and complicated history to build something together that neither could have built alone, to put welders and divers and engineers from opposite sides of a border into the same pressurized chambers, the same impossible depths, chasing the same 5mm target in total darkness where nobody could see the flag on anyone else's uniform. And to come out the other side, not just with a tunnel, but with proof that the deepest, darkest, most crushing barriers on this planet were never really about pressure or distance at all. They were about whether anyone was willing to meet in the middle, whether 2 proud nations could set aside decades of tension long enough to solve a problem that mattered more than either flag. This one did. 800 kilometers of human defiance now glow quietly in the dark beneath 2 of the largest economies on Earth, carrying passengers past creatures that have never once seen the surface of the sea, connecting 2 coastlines that spent generations separated by nothing but water and history and pride. And somewhere down there right now, 40 atmospheres of ocean is pressing against a wall of glass and steel that refuses to give. A reminder that the only thing standing between impossible and finished was ever just enough people willing to go down into the dark and try. Consider what it actually took to get here, because the number $200 billion is easy to say out loud and almost impossible to truly picture until you break it down piece by piece. Every single kilometer of this crossing consumed resources on a scale that dwarfs most nations' entire annual infrastructure budgets, funneled through a supply chain that had to function perfectly 24 hours a day for the better part of a decade, moving parts, food, oxygen, and specialized equipment across 500 kilometers of open ocean to a construction site that technically didn't exist on any conventional map. Ships ran around the clock. Helicopters ferried critical replacement parts when seconds mattered more than money. An entire logistics network, invisible to the millions of people who will eventually ride this train, had to be built from scratch just to keep the actual construction alive. And if that supply chain had failed even once at a critical moment, the entire multi-year timeline could have unraveled in a single week. Thermal management became its own quiet battlefield, because friction at these depths generates heat that has nowhere natural to escape, and engineers had to design systems capable of pulling that heat away from sensitive machinery before it warped metal that had been machined to sub-millimeter tolerances. Every single component, from the smallest bolt to the largest boring machine, had a digital twin, a perfect virtual replica constantly updated in real time, so that engineers on the surface could predict problems before they ever happened underground, catching stress fractures and material fatigue days or even weeks before they would have become visible to the human eye. This is the invisible infrastructure behind the visible miracle, the thousands of small, unglamorous decisions that never make it into a highlight reel, but without which none of the glamorous moments would have ever been possible. And through all of it, through the fault line scare, through the 6-day shutdown, through the 80-ton panels that had to be discarded over a single scratch, through years living in pressurized chambers breathing engineered air, the people who built this tunnel kept returning to the same simple idea that guided every decision from the very first excavation to the final inspection. That some things are worth building, not because they are easy, but precisely because they are almost impossible. Because a species that only ever attempts the achievable never actually discovers what it's truly capable of. Today, trains cross beneath the sea in 40 minutes carrying commuters, families, and tourists who barely think twice about the ocean pressing down on the glass beside them, unaware of just how close this entire project came to failure more than once, unaware of the divers who lived for weeks in tiny pressurized chambers to finish a handful of critical seals, unaware of the 6 days when the whole endeavor teetered on the edge of collapse over a single, unexpected tremor in the seafloor. They simply see the fish drifting past the window, hear the faint, ghostly echo of a whale song piped through hidden speakers, and feel for just a moment like they are floating somewhere between two nations and two seas, weightless, safe, and utterly amazed. That feeling, more than any statistic in this video, is the actual return on $200 billion in a decade of relentless human effort. It is proof, glowing quietly in the dark 800 kilometers long, that the ocean floor is no longer the edge of what humanity can reach, and that when two nations decide a border matters less than a shared achievement. There is genuinely nothing on this planet, not pressure, not distance, not history itself, that can stop them from meeting exactly in the middle.